Okay. Okay. Now, for example, let's take this example. You have I. Suppose I is 2 to 0 root x upon root x plus root 2 minus x. We know that f of x from a to 0 is the same as f of a minus x from a to 0. So, therefore, I can also be written as root of 2 minus x, because here a is 2, upon, instead of x you put 2 minus x, and this one will be 2 minus 2 plus x, because wherever there is x, you are putting 2 minus x. Here instead of x, you are putting 2 minus x. Instead of x, you are putting 2 minus x. So this is 2 minus 2 minus x. So eventually, this is also root 2 minus x upon root 2 minus x plus root x. So we know that I, whether it is root x upon root x plus root 2 minus x, root 2 minus x upon this, both are one and the same. Add the two equations. You get 2i is equal to integral of root x plus root 2 minus x. Denominator is common for these two. It is again root 2 minus x plus root x, which is even dx, which is eventually 1 dx, which is nothing but x. So I is going to be x by 2 in the range 2 to 0. So it's going to be 2 by 2, that is 1, minus 0 by 2, which is going to be 1. So the value of this is 1. Right? So right, we have it that way. Let's take this one. We have integral of x square minus 1 upon x square into e raised to x plus 1 by x dx in the domain 2 to 1. Now here we have to do the substitution process. So let t be equal to x plus 1 by x, e raised to x raised to 1 by x. Therefore dt would be equal to e raised to x plus 1 by x into d by dx of x plus 1 by x, which is going to be denominator, which is actually x square plus 1 upon x d by dx of this. So this is eventually going to e x plus 1 by x into, using quotient rule, denominator is x, so we get x square, then denominator x into d by dx of x square plus 1, which is 2x, minus x square plus 1 into d by dx of x, which is 1, this whole thing dx. So it's eventually e raised to x plus 1 by x into 2x square minus x square minus 1 by x square dx. So it's eventually e raised to x plus 1 by x into x square minus 1 by x square dx itself is dt. So when you take e raised to x plus 1 by x as t, this whole thing itself is dt. So eventually this would become 2 to 1 dt, which is nothing but t to 1 dt, 2 to 1 dt. Yes, 2 to 1 t. Now, there is one more very important thing in case of definite integral, that when should we keep it as 2 or will it change? Now here the limit is bound to change. See, we have to prepare a kind of a table here. When you change the variable in case of definite integral, we have to change also the domain. For example, when this is dx, is going to be x. So when x is 2, t is going to be e raised to 2 plus 1 by 2, that is 5 by 2, whatever it is dx. And when x is 1, in the original expression we are given the domain as 1, so it's 1, then in that case it's going to be 1 plus 1 by 1, that is 1 plus 1, 2. So this whole thing will be from 5 by 2 to 2. So it's going to be t e raised to 5 by 2 it is, and this is e raised to 2. So it's going to be from e raised to 5 by 2 to e raised to 2. So eventually it is going to be e raised to 5 by 2 because it's going to be dt minus e raised to 2. This can be now written as e raised to 2 into 2 and a half, 2 and minus e square. So you get e square into e raised to half, that is root e minus 1. I'll explain once more. This particular part could get a little dicey since we are facing it for the first time. This of course is understandable because we have done many questions like this. Now one thing, see the limits, the domain has been given from 2 to n taking x as a variable. Now the moment you change the variable to t, the domain will also change accordingly. We have taken t as e raised to x plus 1 by x. So that means if you take the upper limit as 2, in that case t would become e raised to 2 plus half, e raised to 5 by 2. So it becomes e raised to 5 by 2. The lower extent of the domain is 1, so in that case t will become e raised to 1 plus 1, that is e raised to 2. So with t you are going to be e raised to 5 by 2 upon e raised to 2. Or the other option that is there is you will have to substitute back as e raised to x plus 1 by x and substitute the values as 2 and 1. It's all the same. So it's going to be, hence eventually, since ultimately the integral value turns out to be t in the domain e raised to 5 by 2 minus e raised to 2, it's going to be f of b minus f of a. So it's going to be, instead of t you put e raised to 5 by 2 minus e square. E raised to 5 by 2 is nothing but e raised to 2 into e raised to half, because it's e raised to 2 plus half. Take e square common and you get e square into root e minus 1, and there is no k in this case because it's a definite integral. So it's going to be option number A. Okay. Okay. Now here also we have a similar kind of a thing. Now it's going to be, we can split this up as 3 to 0 f of 5 minus x, right, plus 0 to 2 f of 5 minus x. We are using the formula ACB process. Then minus, same way, f of x from 3 to 0 dx plus f of x dx, integral of that from 0 to 2. This is going to be nothing but 3 to 0 f of 5 minus x and minus integral of 3 to 0 f of x dx. Then this one is f of 5 minus x dx, integral of that in the domain 0 to 2. Then this minus of this minus f of x dx in the domain 0 to 2. Now we are using the formula that f of x dx, integral of that in the range a to 0 is the same as f of a minus x dx in the domain a to 0. So if you see, this and this are equal, so they get cancelled. This and this are equal, they also get cancelled because the range is the same. Okay, so then ultimately the answer is D. Okay, okay, okay. Now here we have e raised to x minus e raised to minus x from 1 to minus x. minus 1. Okay. Now, if you see f of x, we can do it in various ways. We can do it the usual way. F of x is going to be e raised to x minus e raised to minus x. Now, let us see what is f of minus x. F of minus x is going to be e raised to minus x minus e raised to minus of minus x, that is x. Right. So it's going to be, this eventually is going to be taking minus common. It will become e raised to x minus e raised to minus x. That means f of minus x is the same as minus f of x. If you look at it, you're taking minus common, so you get e raised to x. Now if you see, these two functions are opposites of each other. That is, f of minus x is the opposite of fx. So what type of function is that? Odd function. And the range is from 1 to minus 1, a to minus 1. We are using the rule f of x dx is equal to 0 if it is an odd function. And it is equal to 2 times f of x from a to 0 if it is an even function. Now among these, obviously it's an odd function, so the answer has to be 0. Let's see. Okay, just 0. Okay, now we have a simple one, x square plus 3x plus 2. So it's eventually, what will it be? We're going to find out dx of this. So we're going to do it x cubed by 3 plus 3x squared by 2 plus 2x from 4 to 1, which is going to be 4 cubed by 3, that is 64 by 3, plus 3 into 4 squared, that is 3 into 16 by 2, plus 2 into 4, that is 8, minus 1 cubed by 3, 1 by 3, minus 3 by 2, minus 2. So we have found out the integral. 64 minus 1 by 3 is 63 by 3, and it is going to be 24 minus 3 by 2. Yes. 24 minus 45 by 2. And then you have all these other things. 8 minus 2 plus 6 minus 1 by 3. So we substitute all these values, 64, 63 by 3, and then you get accordingly, which is going to be 62 by 3 plus 45 by 2 plus 6. So this is how we find the value of this. Okay, much the same way you have here x cubed plus 4x squared. So here this is going to be what? X raised to 4 by 4 plus 4x cubed by 3 plus 5x from 3 to 1. So this will turn out to be 3 raised to 4, which is 81 by 4 plus 4x cubed, 4 into 3 cubed by 3. So 4 into 3 squared, 36 plus 15 minus 1 by 4 minus 4 by 3 minus 5. We have found out the integral, and then it is going to be f of b minus f of a, which is going to be this. Simplify this and you get it. This is eventually 80 by 4, that is 20 plus 36 minus 5 plus 10, and accordingly minus 4 by 3, minus 4 by 3. So it's going to be 20 plus 36 plus 10, so 66 minus 1 and 1 by 3. So it's going to be how much? 64 and 2 by 3 will be the answer for this. Okay, x dx upon x square plus 2 in the range so and so. So here it's going to be upon x square plus 2. So x dx. So let we can do by substitution. X square plus 2b equal to t. So 2x dx is equal to dt. So x dx is dt by 2. Another thing is, now we have x and accordingly t, because this is definite integration, so we need to check the rule. Now when x is 2, 2 square, 4 plus 2, t becomes 6. When x is 1, 1 square plus 2, 3. So that means this now becomes from 6 to 3. X dx is nothing but dt by 2 upon x square plus 2, 1 by 2. So eventually it's going to be half log t, which is going to be half log 6 minus log 3, which is going to be half log 6 by 3, that is log 2, which is nothing but log 2 raised to half, which is going to be log root 2. Hence the answer is going to be log root 2. Okay. Then you have the value of 1 plus log x upon x dx is so and so. Okay, from e to 1. Okay. Let's see what we have. We have 1 plus log x dx. You can take 1 plus log x as, say, t. So dx upon x is equal to dt. Now we need to check the range x and t. Right? So when x is e, t will become 1 plus log e. When x is 1, t will become 1 plus log 1, which is nothing but 1 itself, because log 1 is nothing but 0. 1 plus 0, 1. So eventually the whole thing, this whole thing, e to 1, 1 plus log x upon x dx will turn out to be, instead of e, you're putting 1 plus log e to 1, and dx upon x is nothing but dt, and 1 plus log x is t dt. So it's eventually t square by 2 from 1 plus log e to 1. So it's eventually 1 plus log e. So 1 plus log e, the whole square by 2, minus the other one is 2, 1. 1 square by 2, that is half. So this is 1 plus log e is nothing but log e is nothing but 1. So it's going to be 1 plus 1 by 2 minus half. So it's going to be 2 square, that is 4 by 2 minus half, which is going to be 3 by 2. Remember, the whole thing is not square, it is just 1 plus log e the whole square. So instead of log e you can put 1. So 1 plus, because log e value is nothing but 1. So 1, instead of t square you put 1 plus log e the whole square. Then again instead of t you put 1 square, which is 1 upon 2. So it's going to be 4 by 2 minus 3 by 2. So among these, 3 by 2 is the answer. Alright. Then here you have from e raised to x plus e raised to minus x. We can do it the same way. If you take the derivative of, if you take the 1 to 0, e raised to x plus e raised to minus x dx is nothing but e raised to x minus e raised to minus x. because if you take the derivative. So it's going to be e raised to 1 minus e raised to minus 1 minus e raised to 0 minus e raised to minus 0, which is going to be 1 minus 1 0. So it's going to be e minus 1 by e, or rather e minus e raised. This part is going to become 0 because it's 1 minus 1, which is 0. So it's e raised to 1 minus e raised to minus 1. Option number A. Okay. Okay, now we have 2x upon 1 plus x square, which is similar to just the concept of substitution only. So we can say let t be equal to 1 plus x square. So we have 2x dx is equal to dt. So hence again you have x and t. Okay, so when x is 2, t is going to be 1 plus 2 square, 5. And when x is 1, t is going to be 1 plus 1 square, 2. So eventually this whole thing will be in the domain 5 to 2. 2x dx becomes dt and 1 upon 1 plus x square, 1 upon t. So it's going to be nothing but log t in the domain 5 to 2. So it's going to be log 5 minus log 2, which is log 5 by 2 to the base e, obviously it's taken for granted. So it's going to be option number A. Okay. Okay, now we have dx upon 1 plus x, dx upon 2 plus x. So we will have to first integrate and find this out. So it's going to be a upon 1 plus x plus b upon 1 plus x is going to be 1 upon 1 plus x into 2 plus x, which means that a into 2 plus x plus b into 1 plus x is equal to 1. So you put x as a simple partial fraction. Suppose you put x as minus 1. You get b 1 minus 1 0, 2 minus 1 is, so a will turn out to be 1. If you take x as minus 2, then minus 1 minus 2 minus 1 minus b is 1, so b is minus 1. So ultimately this whole thing will be integral of a is 1 upon 1 plus x dx minus 1 upon 2 plus x dx, which is going to be log 1 plus x from 1 to 0 minus log 2 plus x from 1 to 0, which is going to be log 1 plus 1 2 minus log 1, which is in any case 0, minus log 2 plus 1 3 minus of log 2, that is plus log 2. So which is going to be log 2 minus log 1 is 0, and there is 2 log 2. So there are 2 log 2s minus log 3, which is going to be log 2 square minus log 3, which is nothing but log 4 minus log 3, that is log 4 by 3. So it's going to be option number B, that is log 4 by log 3. So what have we done over here? The first part is log 1 plus 1, that is this one, 2. Then log 1 plus this 0, which is going to be log 1. Then we come to log, the next one, minus log 2 plus 1, that is log 3, minus log 2 plus 0, log 2, but it is minus of minus, so plus log 2. So now this log 1 in any case is 0, log 2 and log 2 is 2 log 2. or we can write it as log of 2 into 2. So it's going to be log 4 minus log 3, log 4 by 3. Okay, so we have log 4 by 3. Let's see what we have on the anvil next. Okay, this is a very simple one. You have 4 to 1. So it's going to be 2x plus 5 dx. So we are going to use special variable. Yes, so it's going to be 2x plus 5 dx. So it's going to be 2x plus 5 the whole square by 2 into 1 by 2 from 4 to 1. So it's going to be 2x plus 5. 2 4s are 8 plus 5, 13 square by 4 minus 2 1s are 2 plus 5, 7 square, 49 by 4. So it's going to be 169 minus 49 by 4, 120 by 4, which is nothing but 30. It's going to be 30. Okay.